All right, hello guys. We're going to take a look at 3 different kinds of angles today to add to our knowledge of the unit circle and evaluating some trig functions. So we're going to start with negative angles, and that will lead us into coterminal angles. And then we'll touch base and review quadrantal angles because I know we've talked about them over the last couple of days, but we're going to fully and formally look at how we can use them beyond the unit circle. All right, so let's take a look at negative angles first. So when we first started plotting angles in standard position, we know standard position has the initial side on the positive x-axis, and then the terminal side, all the angles we've been looking at, the terminal side has gone up and around in a counterclockwise direction, right? Like these dots are 30, 45, 60, 90, 120, 135, 150, 180, and so on, right? We've gone up and around. All these angles that we've been looking at have all had positive measures. Well, if we were to start at the positive x-axis, but then go down and around in a clockwise direction, those angles would be measured with a negative angle value. So a negative angle rotates around the unit circle in a clockwise direction, down and around, like I was saying. And then we give them negative angle measures. So for example, negative 30 would rotate if we follow the same measurement of the dots, like this is positive 30, 50, 45, 60. We could do the same thing. This would be negative 30. From here to that first dot would be rotating negative 30 degrees. So the negative indicating that we're going down from that positive, from that initial side. So we could call this point A. In the same way, B, negative 75. So if this is negative 30, that would be negative 45, negative 60, negative 90. So negative 75 is in between here somewhere. So we could just eyeball it and say around here is negative 75 degrees. That would be point B. Negative 90 would be that negative y-axis. So this would be point C, negative 90 degrees. D, negative 150. So if from here to here is negative 90, where am I? Here we go. Negative 90, so this would be another 30 degrees, negative 120, negative 135. Here's negative 150. So we would say this point right here, negative 150 degrees is point D. Point E, negative 180. So notice negative 180 and positive 180 are the same spot because we're rotating both directions 180 degrees, which is a straight line. So they happen to end at the same spot. And then the last one they want us to plot here, point F is negative 200. So remember the distance from our x-axis to this point is 30 degrees. So negative 200 would be about here. Point F. Okay, so again, big thing here is that positive angles starting from the positive x-axis go up and around, negative angles go down and around. So hopefully what you notice is, hey, yeah, these points have these negative angle measures, but we know them differently, right? Like we know this point to be 330 with a reference angle of 30. We know this quadrantal angle to be 270 degrees, right? This was positive 180. This point here is also 30 degrees from 180, which is 210. So we see that these points, although we've rotated them down and around and we have a negative angle value, these same exact points also have positive angle values. Angles that have the same starting initial side and the same terminal side, like this one. So the negative 30 was going down where the positive 330 went up and around. Notice these are 2 different values, but the same angle, the same initial, same terminal sides. Angles like these are called coterminal angles. So coterminal angles, like we see here, we'll use a different color here. So coterminal angles, they have the same initial and the same terminal sides. The difference is the direction that they're rotating. but also how many times they're going around. So for example, I could give you a brand new one. Let's look here. So those were negative. One of the angles was negative. What if we took this point, this angle that rotated, that opened up 30 degrees? What if we drew another angle starting at the positive x-axis, and then it rotated around once, which would be 360, and then it ended at the same spot? So rotated around one full rotation, and then, one full rotation, and then the additional 30. That angle measure would be 390 degrees. Notice, again, the purple and the orange angles start at the same spot, end at the same spot, but the number of rotations around the circle were different, right? So we see a bunch of examples where angles that look the same can have different measures. And again, those are called coterminal angles. And hopefully what you see with all these measures, negative 90 to 270, negative 150 to 210, negative 180 to positive 180, 30 to 390, if you did the math, you would see they all differ by 360 degrees. So coterminal angles, you can think of them in two ways. Like 30 to 390, we added 360. If you were starting with 390 and wanted to go back to 30, you would subtract 360. Same thing with 125 to 485. 125 plus 360 would give us a coterminal angle of 485. If you were starting with 485 and wanted to find a smaller coterminal angle, you would just simply subtract 360. And we can do the same thing with negative and positive angles. So we could subtract 360, or we could add 360, depending on what angle value is going to help us out the most. All of these examples are angles that look the same but have different measures. Okay, so we could find the smallest positive coterminal angle, like this direction tells us, find the smallest positive coterminal angle, and really all that tells us to do is either add or subtract 360 until we get the smallest positive number we can. So for example, to find the coterminal angle to negative 30, we would add 360 and get positive 330 degrees. From negative 150, we would add 360 and we would get positive 210 degrees, which is, remember, what we were saying anyways. We know this point to be 210 degrees. That's what we've been working with so far. But now if we throw negative angles in there, we can give it a different name. Again, coterminal angles. Okay, if we added 360 to negative 180, that would give us positive 180. And we could keep doing this with all of them. Negative 90 plus 360 is positive 270. Negative 75 plus 360 would give us 285. And then negative 200 plus 360 would give us positive 160. Again, all examples of angles that if we were to plot them around the unit circle would start and end at the same spot, but the direction, whether it's positive or negative, and the amount of times that we went around the unit circle would be different. Okay, and we're going to look at worksheet 4 in a second. I'll show you how we're going to work that into what we've been working with so far. So just hang tight. Let's talk about quadrantal angles really fast, and then we'll go to our worksheet 4. So quadrantal angles, we know are angles. We've talked about these before. In fact, I'm going to go ahead, take a white pen and make it real big, and go ahead and block this out. I'm going to change the notes a little bit, just to be consistent with how we've been talking about it. So quadrantal angles are angles whose terminal side are on the X or Y axis. So we know the quadrantal angles are at 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then 360 is the same spot as 0. We also know all the coordinate points at these angles. So 1, 0, 0, 1, and -1, 0, and then 0, -1. So knowing these basic coordinate points of the quadrantal angles, we can, like we've been practicing, we can evaluate lots of different trig functions. Like I could ask you, what is sine of 270 degrees? So sine is the same as the y value. The y value of 270 is -1. We could say, what is cosine of 90 degrees? Well, cosine is the x value. At 90 degrees, cosine is 0. Okay? In the same way, we can look at the reciprocal functions like cosecant of 270. Cosecant of 270 is just the reciprocal of sine, or r over y. With quadrantal angles in the unit circle, r is always 1. And then again, the y value at 270 is -1. So the cosecant of 270 would also be -1. We could do the cotangent of 0 degrees. Cotangent, remember, is x over y. The x value at 0 degrees is 1, y value is 0. This would be undefined. So we can use these quadrantal angles, figure out all the trig functions. And then the next step, what you're going to see is we're going to see expressions with quadrantal trig functions in it. For example, 3 times cosine of 270 minus, let's see, cosecant squared of 180. We can see an expression written out like this, and what we would do is use the trig function with the quadrantal angle. We would evaluate that. Notice how we're squaring this one. So I'm just going to put placeholders in with our parentheses, and then I'm going to draw a picture inside the parentheses. So this one's at 270, so down here. Cosecant's 180, so right here. And I'm just going to remind myself cosine is the x value. So this point is 0, -1. So the x value is 0 here. Cosine of 270 is 0. Cosecant of 180. So cosecant is r over y, like we were talking about. R is 1. The y value here is 0. So this one would be an undefined value, so we just kind of like ignore it. So we leave here 3 times 0 is 0. So this expression would equal 0. Okay, so we can take our experience with quadrantal angles, kind of apply it with our reciprocal functions, but then also we can use it with evaluating some expressions. Okay, so before I let you go ahead and take out your worksheet packet, and I want to do just a couple questions on worksheet 4, just to make sure we're all on the same page here before you get working on it. So pause the video if you need to, but I'm just going to go right on ahead. So there's a couple sections in here. The first section's numbers 1 through 4 want the smallest positive coterminal angle, right? And so remember, that's just adding or subtracting 360 degrees. So if it's a really big angle that's more than 360, we're going to go ahead and subtract 360 to get the coterminal angle. If it's a small negative angle, then we'll add 360 to get the coterminal angle. Okay? Now, taking this whole idea of adding, subtracting to get what we to get a smallest positive coterminal angle, we do that because we have a lot of experience with angle measures within one rotation of the unit circle, right? One with kind of the unit circle that we've created. So the next section, you see they bring up the trig functions, but all of a sudden the angles aren't the ones that we're super familiar with. So in these cases, we're going to use the coterminal angles. So this is negative. We'll add 360 and get 120. Negative 240 and 120 degrees land at the same spot in our unit circle. They both land in the second quadrant. They both have a reference angle of 60 degrees. So instead of thinking of this as memorizing or working with angles we're not familiar with, we can use coterminal angles to get an angle we're more familiar with. and then follow the exact same steps as before. This is a reference angle of 60 degrees, so we're thinking what's cosine of 60? That is 1/2. It is in the second quadrant. 120 is in the second quadrant. In the second quadrant, x is negative. So our answer is -1/2. So it's the same steps as we've been working with, just a preliminary step of getting an angle that we like better. That's in one rotation of the unit circle. So like for number 10, I'll start you off. This is really big, right? 585 is more than one rotation around the unit circle. So the first thing we're going to do is get a coterminal angle and then use that to evaluate the sine of 225. Okay, so I'll let you finish that up. And then again, number 13, just like one of the examples we did in our notes, with these questions, again, you want to use parentheses as placeholders. And as you're memorizing, feel free to draw a diagram, use your ratios, right? Sine and cosine. And with our quadrantal angles, r is always 1. So you can use the corresponding points. So in this case, 0 plus 3 times -1. So your answer is -3. Okay? So feel free to rewind or go back to any of the parts if I went a little too fast. But otherwise, finish up worksheet 4 with your neighbors, and I'll be back tomorrow to answer any questions. Hope you guys have a great day.